Now we look at limiting reactant questions. Now, at first glance, this looks like a standard mass stoichiometry question, but one difference. We're given the mass of both of the reactants, of two of the reactants. Which one are we going to use to calculate moles? Well, when you think about it, if you're mixing two random amounts of reactants, one of them is going to run out first, and at that point, the reaction is going to stop. So it's the amount of the reactant that runs out first which will determine how much product that you get. So our first task with limiting reactant questions is to work out which chemical, which one of the reactants will run out first. Which one is the limiting reactant? So anytime you get a question where you can work out the number of moles of both of the reactants, then it's a limiting reactant scenario. You have to work out the limiting reactant first. Now it's just a little twist on the normal mass stoichiometry process. So instead of just working out the number of moles of one reactant, we've got two of them, so we work out the number of moles of both of them. So in this case we had 10 grams of magnesium and 10 grams of oxygen. Well, we work out the number of moles of both, using the mass formula of course, and we've got the number of moles of both. Now which one of those is going to run out first? Well, we have to do a calculation to see. Now we take one of them, one of these reactants. I'm going to take magnesium. If all of this magnesium reacts, how much oxygen is required to do that? So we just apply want over got to the moles of magnesium to work out how much oxygen is needed to use it all up. So in order to use up all of that 0.412 moles of magnesium, we'll need 1 over 2 times that, 0.206 moles of oxygen. Now how much, so that's how much we need. How much oxygen do we actually have? We've got a whole lot more oxygen than that. We've got more than enough oxygen. That means when the magnesium runs out, that's when the reaction will stop, because there's still more oxygen. It's going to be the magnesium which determines how far the reaction goes. So magnesium is the limiting reactant. There is oxygen in excess. Now, once you've worked out the limiting reactant, you can then go through the rest of the mass stoichiometry problem as normal. So, magnesium is limiting reactant, we'll use that for the rest of it. So, next step of course is want over got, to work out the number of moles of magnesium oxide, 2 over 2 of course. Then, third step of course is to work out the mass of the reactant that we're being asked about. So the mass of magnesium oxide is simply worked out there. Now, we can also be asked to work out the amount of reactant left over. So in this case that's oxygen. Oxygen is the excess reactant. Now also in this case we've been fortunate in that we've done it the right way round. We know that we started off with 0.313 moles of oxygen. We've already worked out how much oxygen is needed, but we can do it again. So we apply want over got to the moles of magnesium to work out how much oxygen will actually react. Then the difference between those will be how much oxygen is left in excess. Multiply by the MR to get the mass. So there we go, that's limiting reactant. Got a second example. What mass of ammonia is produced when 3 grams of hydrogen reacts with 15 grams of nitrogen? Now you might think, oh, there's much more nitrogen than hydrogen, but appearances can be deceptive. We actually have to go through the process, working out the limiting reactant. So again, mass of both reactants is present, we work out the moles of both reactant. Remember the MR, it's nitrogen N2, so it's 2 times 14, it's hydrogen H2, so it's 2 times 1. It gets us the number of moles. Now again, we take the number of moles of one and work out how much of the other we would need to completely react it. So in this case, again, I'm taking the number of moles of nitrogen, multiplying it by 1 over got, 3 over 1, to tell us how much hydrogen we would need. And we see we need 0.1607 moles of hydrogen. We've only got 0.150. We don't have enough hydrogen to react with all the nitrogen. Hydrogen is limiting because we don't have enough of it. That means nitrogen is in excess. So to work out how much ammonia is produced, we're going to use the moles of hydrogen. So 1 over got, 2 over 3 times the moles of hydrogen gives us the moles of nitrogen. Nice round number. Then multiply by the MA to get the mass. And on to the questions. Do the questions and hopefully you get the right answer. Right answer for question 1 is that. Right answer to question 2, I shall try and find it. To the wrong screen there, what have we got? 280. And the right answers to question 2 are there. Have a go at them and I'll send you the solutions if you need.